Welcome back, students. We will discuss some more problems on trigonometry. We are presently solving all the board problems on trigonometry equations. Please refer 9th, 10th and 11th videos to better understand this. Write and practice these all three trigonometric identities, whatever I have discussed in those three videos. I will circulate an important video with a notes or a PDF or a Word file where you can print out and practice it in my next video, not in this, in my next video. So the problem one is 2 cos cube A minus cos A divided by sin A minus 2 cos cube A is equal to cot A. So basically you need to look for patterns. So one pattern what I can see here is cot A is nothing but cos A by sin A. That is exactly what you have in this equation, a mix of cos and sin terms. And you also know the algebraic identity 1 cos square and sin square together brings in 1, but here you don't have square, you have cube. So how I'm going to solve this? I'm going to take out the cos outside so that the numerator part becomes cos A into 2 cos square A minus 1. Somewhere I'm trying to convert this into a trigonometric identity 1 form. Similarly, denominator is sin A I'm pulling out, sin A into 1 minus 2 sin square A. So now we have got cos A and sin A, which is essentially going to give you cot A. So you should look for opportunities to cancel out these terms in the numerator and denominator. So further what I'm going to do is I'm going to bring either the numerator or denominator to a common term, and so I proceed on the numerator. I'm going to convert this cos square to a sin square. So numerator becomes cos A into 2 into 1 minus 2 sin square A. That is the trigonometric identity minus 1. Denominator remains as such. Then cos A into 2 into 1 2, then 2 into sin square A is equal to 2 sin square A minus 1. 2 minus 1 gets um, solved as 1. So in the numerator you have cos A into 1 minus 2 sin square A divided by sin A into 1 minus 2 sin square A. These two terms get cancelled, okay, and you are left with cos A by sin A, which is nothing but cot A. Now you have to solve sin plus A, sin A, sin A plus cosec A whole square plus cos A plus secant whole square plus 7 plus tan square A plus cot square A. So do you see any pattern? I can see two patterns. One is trigonometric identity 2, a mix of tan square and mix of tan square and secant square. And similarly, trigonometric identity 3, a mix of cot square and cosec square. So let us go to solve this. I'm going to just apply a plus b whole square formula to both of these equations. This becomes sin square plus cosec square into plus 2 into sin A into cosec A. Similarly, this equation becomes cos square A becomes cos square A plus secant square plus 2 into cos A into secant A. So now this cos A into secant A is nothing but cos A into 1 by cos A. Cos gets cancelled. Let me put it down here. Cos A into 1 by cos A, where these both gets cancelled. Okay. So you are left with 2 here. Similarly, you have another 2 here. Sin A and cosec A becomes 1. And this sin square A plus cos square becomes another one. You have 1 plus 2 becomes 5 here. Then the remaining terms are carried over. Cosec square A comes here and secant square A comes here. Now this is the equation you have, and you are going to apply trigonometric identity 2 and 3. So it becomes 5 plus cosec square A is nothing plus 1 plus cot square A. Secant square A is equal to 1 plus tan square A. This 1, and this 5 gets added as 7. And the remaining terms tan square and cot square comes over here, which is exactly the right hand side of your equation. Problem 3. 1 plus cot A minus cosec A into 1 plus tan A plus sec A is equal to 2. What I'm going to do is, here I have an opportunity, like cot A is cos A by sin A, and similarly cosec is equal to 1 by sin A. I have in the numerator something which I can help to add. So I convert this cot, tan, everything into sin and cos based problem. So 1 plus cos A by sin A minus 1 by sin A. Similarly, 1 plus tan A becomes 1 plus sin A by cos A. Second A I'm going to put as 1 by cos A. So when I'm going to add it, I'm going to take LCM and add it. This sin A becomes a common LCM here. I'm going to add it. So 1 becomes sin A here, cos A, minus 1. Similarly, for the other term, cos A goes on the denominator. Then this one on addition becomes cos A, sin A. Then this one comes here. Okay. Now important thing, how to proceed with the next step. Now this entire thing you treat it as A. The sin A plus cos A, treat it as A. And this one you treat it as B. So it is like A minus B into A plus B format. A minus B into A plus B is nothing but A square minus B square. So let us put A square minus B square. B square will put first. Minus 1 minus B square comes here. Okay. Then A square I'm going to square it. A is nothing but sin A plus cos. The whole square I'm going to make it. It becomes sin square A plus cos square A into 2 sin A into cos A. Okay. This sin square A plus cos square A is equal to 1, which gets subtracted or cancelled as 0 with this minus 1. So you are left with 2 sin A on the numerator, 2 sin A cos A on the numerator, and sin A on the denominator, sin A into cos A on the denominator. Thereby the answer is 2. So moving to the fourth problem. Cosec minus sin A into sec minus cos A is equal to sin A cos A is equal to 1 by cot A plus tan A. Cot A plus tan A. You have 3 equations. So the approach what I'm going to take is I'm going to take the left hand term, solve it to some extent, show that it is equal to sin A into cos A. Pick up the right hand term, solve to some extent, and show that is also equal to sin A cos A, and thus I'm proving the equation. So cosec A into sin A. Cosec I'm going to substitute as 1 by sin A minus sin A. Sec A is 1 by cos. 1 by cos A minus cos. I'm going to take LCM and add. This becomes 1 minus sin square. This whole term becomes 1 minus sin square A. Similarly, this whole term becomes 1 minus cos square A divided by sin A into cos A. This you can apply trigonometric identity 1. This becomes cos square A. 1 minus sin square A becomes cos square A. Cos square A. Similarly, 1 minus cos square becomes sin square A. So on the denominator you have sin square A into cos square A, and on the denominator numerator you are going to have sin square A into cos square A. On the denominator you have a sin A into cos A, which on simplification becomes sin A into cos A. So on the right hand side now we have proved this part now. This middle term is equal to sin A cos A. Now let me pick up the right hand equation. Straight away what I'm going to do is, here I have a tan, I have a cot, and I need to prove it is equal to sin into cos. So best thing is substitute the value of tan A, cot A, add it. Value of tan A sin A by cos A plus cos A by sin A. Upon adding, the numerator sin A cos A goes up, sin A cos A, on the denominator sin A cos A goes up, and the numerator becomes sin square A plus cos square A, which is equal to 1. So this 1 on dividing gives you answer of sin A plus cos A, which is nothing but the middle term. So you have proved this equation. So in the next video I'll share you what I'm going to share you is a few guidelines how you can solve trigonometric equations along with the published PDF document, so that you can download, write and practice it. Thank you and bye till then.